Welcome to my Kaggle Titanic competition solution. Let me recap if you don't know what the project is about. The Titanic Machine Learning from Disaster project is a beginner Kaggle competition where you use machine learning to create a model that predicts which passengers survived the shipwreck, based on information on each passenger, such as their name, age, sex, and so on. So let's dive straight into it. First, I imported all the libraries needed for this project. You might not have some of the libraries inbuilt such as XGBoost, which you can download online. Next, I read in the training file to see what the data is about. There are 12 columns for each passenger, which includes a column on who survived. The column value is 1 if the passenger survived, and 0 if they didn't. Then we go ahead and get the information about the data to see the data types and amount of null values. I quickly notice that age and cabin contain 183 and 687 cells, with null values. If you observe the data, you will notice a few things. 1. Every name is styled as name, title, and other names. I extracted the title from the data. I got inspiration from Ken G's walkthrough, link in the description. 2. The cabin names are either null or start with a letter, even when multiple cabins are stated in a cell. They usually start with the same letter. So I thought, what if we had every letter extracted and used the null value as part of the prediction? The fact we do not know what cabin the passenger is in could have some effect on the result, which it does. 3. The same line of reasoning for the cabin is done for the tickets. Extracting the first number or letter from the ticket number. However, because the ticket numbers are sometimes two separate strings, I had to account for that too. Next is getting the dummy variables for object predictors using pd.getDummies. I always print the data frame to ensure everything looks alright. After creating dummy variables, I printed out the column names to see all the column names. Again, everything looks fine, so we proceed. Now we get heat maps for survived against all predictors, but because the heat map will be illegible if all predictors are done at once, I have broken it into 6 heat maps. 1. Survived versus columns P-class to fare. The two clear inferences are the more a passenger paid, the higher their chances of survival, and the higher the class of the passenger, the more the chances of survival. So first-class passengers were more likely to survive than third-class passengers. 2. Survived versus titles. Passengers with the title Ms. or Mrs. were likelier to survive, while passengers with the title Mr. were likelier to not survive. 3. Survived versus sex. Not surprisingly, from the inference on titles, females were highly correlated to survival, and males were not. 4. Survived versus tickets. Passengers with ticket numbers starting in 1 were likelier to survive, while those with ticket numbers beginning in 3 were likely to be left to the harsh waters for some reason. 5. Survived versus cabin. No strong enough correlations here, but cabin numbers beginning with B, C, D, or E did have a slight chance of survival. This could be due to these cabins' proximity to lifeboats. 6. Survived versus embarked. Passengers that embarked from Cherbourg were more likely to survive, and those that boarded at Southampton were more likely served to the fish. From all these inferences, to survive, being a first-class female passenger, with ticket numbers starting in 1, staying in cabin with numbers starting in B, and boarding at Cherbourg, will boost your chances. Enough with the data visualization. Now, we split the data into train and test, but because I wanted to have a relatively similar survival split between train and test data, I used the stratified shuffle split instead of the train test split. Here is a plot of how survival is divided between train and test splits. I dropped the passenger ID and age columns on the train and test data and also dropped rows that contained any blank cells, although there were none. Print the training data info to ensure nothing has been broken so far before proceeding. Because stratified shuffle split was used, the training and test data must be manually split into predictor and response variables. I created a function so once I fit the different model, I call the function on the model, and immediately print out how they performed with the test data and get a CSV file for the model that can be submitted to Kaggle. An empty pandas data frame was created to store all the training and test accuracies. This function also ensures the training and prediction data have the same columns arranged in the same way to not break anything. Because the Kaggle competition is focused on accuracy. For every model, I created a class that will optimize for accuracy, inspired by Graham Harrison's post on Towards Data Science, link in the description, because he goes into how to optimize for precision, cost function, and F1 score. Really a solid read. I do this for every model. The classifiers I have gone for are logistic regression, random forest, ADA boost, K-neighbors, gradient boosting, XGBoost, and soft voting classifiers. From all these classifiers, gradient boosting performed the best on the test data with an accuracy of 86.59%, and random forest performed the best on the training data with an accuracy of 94.24%. Using the test data accuracy as the decider, gradient boosting is to be submitted, but then I got greedy and thought to tune the model further using grid search CV, tuning in estimators, loss, criterion, max depth, and max features parameters. The grid search took a bit of time, almost 10 minutes, and produced the following parameter, n estimator of 50, using exponential loss, criterion of Friedman MSE, max depth of 5, and max features of square root, with a test accuracy of 83.2%, which is lower than the first test accuracy score. Once I submitted the CSV, the tuned model had a Kaggle score of 0.78. Before tuning, I submitted the pre-tuned gradient boosting model and that got a Kaggle score of 0.77. Thanks for watching, and please comment on aspects I could have done better, ideas, tips and more to improve. Also, if you have any fun projects you are working on, I am happy to team up. Catch you in my next video, and God bless.